Hello guys, welcome back to my channel, Mason African Motives. Still working on mathematics N4. So in this platform we shall just have a continuation from the question paper that we were still working on which was written in February 2022. So actually we want to see what we're supposed to do on this question 4. As we can see, it is a total of 20 marks, just like I said, according to the way that they are now doing the work. Each and every question must have 20 marks like that. So the first question there on question number 4.1 is to solve for x, and we are given 4 marks for that. All right, these are some of the questions that we are supposed to actually take note about. We have got 3x squared plus 3x plus 3, which is equal to 0, like that. So actually what I could do is to solve. Maybe I try to factorize, I try to apply the quadratic formula, but actually by just looking at these numbers we will see that we do not have any common. Yes, we can factor out 3, but you will see that whatever that you're going to remain, it won't be, you won't be able to factorize this. It's not possible. So what now are we going to do according to the type of the equation that you're going to do? Actually, this type of an equation, according to your level, which is in N4, it's under complex numbers, where you're supposed to solve the normal way you do to a quadratic equation, that is using the formula. So let's see what you're going to have if we are to apply the formula in this case. So according to this part, we have got our A, our B, and our C. So we can actually just substitute into the formula. That's minus B, which is our B in this case is 3. So it's minus 3, all right, plus or minus the square root of, all right. So in this case, we have got B squared. So you could have used this one, which is equal to 0, like this, if you want. Okay, it's one and the same thing actually. But for those who just use the equation as it is, maybe you couldn't see that you can factorize, then you just have to apply the normal way. That is why I'm doing this, guys, so that we don't miss each other here. So this is 3, and everything over 2 times A, which is our A in this case, is 3. So I just want you to see the disadvantage of using this with 3 is that you must be good at factorization later on, but this one there was no need for factorization. You just apply your quadratic formula direct, then your answers there direct. But here, okay, I'll show you what you're going to have here. This is going to give us -3. Always I tell you guys that if you are solving a quadratic equation, first try and simplify and know what is under the square root. Not just to use your calculator at once. There is going to write maths error depending with the type of calculator that you are using, to show you that what you are doing is not applicable or cannot be simplified in maths. So simplify this part under the square root first, so that you see what is going to happen. So in this case, you are going to obtain -27, everything over 6. Okay, don't be surprised about this negative here, because we are in complex numbers. It represents a great significance here, where we know that square root of -1 is equal to I, or some can use J. I actually favor to use this J, because guys, we are in engineering, and in engineering we know that this I mostly we use it when it comes, or when it concerns current. So yeah, let's just be mathematical, guys. Let's just use J, or you can use I. It's one and the same thing actually. All right, so which means wherever I see this negative under the square root, I'm going to replace with a J. So I can write this as -3 plus or minus the square root of 27 with a J aside. And this J is not inside the square root, it's outside of the square root, like this. this j, it's outside of the square root. It's only 27 which is going to remain under the square root. We have simplified this because it means square root of -1 times square root of 27. That is what this part means. So from your complex number, this is j, so it's j times square root of 27, which is j square root of 27, or you can write as 27 square root of 27j, like this. Okay, remember, everything over 6. At that stage, you are going to simplify now this square root of 27, this one, because it's now a positive. This one, it's now separate. You have taken the negative out, which is this j here, so you are left with 27. So from your calculator, the square root of 27, it's actually 3 square root of 3. That is 3 square root of 3. So that means you are going to have something like this. X is equivalent to -3 plus or minus. So you can start with the j, or you can write j later on, depends with what you want to do. Now square root of 27, this one gave us 3 square root of 3, so it's going to be 3 square root of 3, like this. But remember, everything is over 6. So we have got our solutions now, so we can actually separate them. How do we separate? We can actually factor out a negative, like I was saying here, the 3 is common, so you have to factor out. But if you had used that other equation, you are not going to face this part, but here you have to factor out 3 because 3 is common here on top. This one and this one, not this one inside the square root. You can't factor this part under the square root. You can factor out these two because there's a sign in between here, so that is why you can separate, because these are two separate terms. All right, so if I factor out 3, I'm going to be left with -3 divided by 3, which is -1, plus or minus 3, and 3 will cancel, which means you're going to be left with the j square root of 3. Guys, j1 square root of 3, this one does not matter. Okay, everything over 6. So these two can reduce each other because you're multiplying, so you've got the power to reduce this. So 3 over 6 from your calculator, that's 1/2. So it means, or you can just reduce 3 into 3, guys, that's 1, 3, that's 2. So which means on top you're going to be left with -1 plus or minus j square root of 3 over 2, like this. So someone can separate this, or you can actually leave it like that, but someone can separate to obtain two solutions, one with a plus like this. X is equal to -1 plus j square root of 3 over 2, everything over 2, like this, or x is equal to -1, negative this time, j square root of 3 over 2, like that. So it depends with the way that you want to do or to use. So, but if you could have just reduced this and worked with this equation, it was going to be much easier, because it was just going to be x is equal to -1 plus or minus the square root of 1 squared minus 4a, which is 1, times c, which is 1, everything over 2 times 1, which is 2. So you're going to obtain x is equal to -1 plus or minus the square root of this one is going to give us 1 minus 4, which is -3, everything over 2, like this. You see, so your x was going to be -1 plus or minus, remember square root of a negative, it's j, so you're going to be left with the square root of 3 over 2. So you see, if you could have reduced this equation like this, it was going to be much easier than to work with the normal equation as it. But as you can see, under exam condition, maybe you couldn't see that you can reduce the equation. You worked with the original equation as it was. Therefore, don't forget to factor out at this stage, okay? Because that one, it's a common term or the one that you were supposed to have factored out in the first place. But anyways, that's what we had. Let's see the other part on 4.2, where we are asked to express in the form of a plus jb, which is the rectangular format. So this is actually the rectangular format. So there we are supposed to do the proper working. How are we supposed to do this, guys? We are given now that's 2 angle of 30 degrees, and according to the presentation, I'm just taking according to what I'm seeing, because here we don't know, is this a degree or what? Okay, and here, as you can see, we're just given an angle of 60. We do not have the number there, so I don't know how they actually wanted to write this, but let's just take according to the way that I saw, and we just work according to that. If there is any other way that is clear, we'll see it in the next class. But this is what actually I saw, and what we're given. And also the other thing of the presentation, remember this is the same format that we are having, so it actually surprises us if we are given two formats. This format and this format is the same. So I wonder why writing the cis where there is also this format here, because it's one and the same thing. But anyways, that's what we're given, but I don't know what was the reason for that, because that is the same format. Anyways, the question is asking us to express this in this format, which is the a plus jb. Show all necessary steps. Yeah, so because they know that some of you can use your calculators here, but they want you to show the steps. So what are you going to do, guys? Let's start first down. We know that here, if the number is not given, therefore we're just going to use it as a 1. All right, so what we are going to do is to apply the laws and the concepts that we have. All right, we know that in polar form, because this is polar form that we have, that we want to convert to rectangular form. When you are multiplying like this, you multiply these numbers together, then the angles, you add them. So you add the angles, you multiply the numbers together. So it's 2 times 1, which is 2. Then you add 30 plus 60, which is 90. You add like this. So 30 plus 60, which is 90. So that is what you're going to have. So you move on to this part here. There is an exponent here, so which means you're going to apply the de Moivre's theorem, which says that if there's an angle, this is going, there's an exponent, this number is going to be raised to the exponent, and the exponent multiplies the number like this. Let me write it like this: r theta, like this, to the exponent of n is equal to r to the exponent of n theta, like that. So that is the concept, guys. So you raise to the exponent, that's 3 to the exponent of 2, like this. 3 to the exponent of 2 n theta, our n is the exponent, so it's 2 times 20, like that. So that is the presentation. So 3 to the exponent of 2 is 9, and 2 times 20, that is going to give us 40 degrees, like that. So as you can see, it's a direct concept, actually. Direct, yeah, it's direct. Once you know this, then you can actually apply it direct, like that. Everything of like I was saying, this is here is same as this presentation. You can write this part here as 2. It was 230, like this. It's the same as writing as 2 cis 30 degrees. It's just one and the same thing. So since already we have written this in this format, therefore let's just write also this one in this format. So it means this part, the one that you are seeing here, is not different from the one which was supposed to be written like this: 4 angle of 70 degrees, like this, by 3 angle of 30 degrees, like this. It's just one and the same thing. So that is what I'm trying to say there. So that means you can actually apply the same concept that you did here to multiply the numbers together, which is 4 and 3, which is 12. Then we said we are going to add the angles. So you add 70 plus 30, which is 100, like that. All right. Still, same concept on top here, because these two, they are still multiplying. So 2 and 9, which is 18. And remember the angles we add. So it's 90 plus 40, which is going to give us 130, like this. Everything over 12 angle of 100. Now the story has changed, because this time you are dividing. You are no longer multiplying. This time you are dividing. So what are you going to do? You subtract. If you are given such, you subtract the angles. All right. So the angles this time you have to subtract them. But the numbers you divide as they are. So it's 18 divided by 12, like this. These numbers, you divide them as they are, which is going to give you 1,3 angle of. The angles now are the ones that you subtract. When you multiply, you add. When you divide, you subtract. So it's 130 minus 100, which is going to give us 30 degrees. All right. Why are we doing this? We want to have a resultant which is in polar form. Remember, we are still in polar form, but we are now having a resultant. We are now having an equivalent which is easier for us to convert to Cartesian form or to rectangular form. All right, so how do I convert this 1,3 angle of 30 degrees to Cartesian or to rectangular form? Okay, remember, if I am given r theta like this, if this is in polar form, I can write this as r cos theta, okay, plus rj sine theta in rectangular form. Okay, so that is the concept. I'm going to show you another way of using a calculator to just prove that. Okay, so which means this can be written as, this is your r theta, your r is 1,3, your theta is 30, so it's going to be 1,3 cos theta, which is 30 degrees, like this, plus r, which is 1,3 j sine theta, which is our theta is 30 degrees, like this. All right, so now you have to simplify this together. This one, that one, you can simplify 1,3 cos 30 from your calculator and make sure that your calculator is in degrees. You're going to obtain something like 1,126. All right, then this part here, remember the j here is an indication of what, of being in rectangular form. If you are in rectangular form, you must see this j or this I. Remember, I told you can use any of these two. So which means you ignore this, then you use your calculator to simplify 1,3 sine 30. Okay, so 1,3 sine 30 is going to give you 0,65, but remember there is a j there, so it's going to be j 0,65, like that. So you ignore this j because it's not there on your calculator, then you simplify these two. All right, so that is what you're going to have. Or if you wanted, you can actually prove this on your calculator. I don't know if it is going to be clear. Okay, let's see, there's too much light. Anyways, this is what you're going to do. You just have to change your mode. That is in this case here we have got polar form, and there's too much light now, guys. Okay, we'll see that one out another part, but this is what you need to know according to your syllabus. Anyways, we'll see that one another time. I'll try to make a nicer setup. On 4.3, we are then asked to make any the subject of the formula from this whole equation. We want to make n to be the subject there, which is on 4.3. Yeah, let's just see what we had. P is equivalent to R over Q. Then we are given log, that is the nth root there. So this n is actually inside like this. Then we've got x minus t like this. And we want to make n to be the subject. So which are these stages are we going to take in this case? All right. I just want us to see something here. If we are to cross-check, the n that we want is actually part of this log here. So let's try and remove this part here, which is p over r, this one, because it's multiplying. So if we multiply by q over r both sides, we multiply by q over r both sides, that means we can actually remove this. All right, so that means we are going to remain with the q times p, that's pq over r like this, which is equal to, so you have removed this, we are left with log, so it's going to be log the nth root of x minus t. All right, now we can clearly see the part that we want to make the subject here, but let's start by resolving this from your laws of exponent. The nth root means it was raised to the exponent of 1 over n. That is what we understand. All right, so that means we can rewrite this. Let me just try adjust this part. So it can be written like this now. That is log x minus t like this. Then this whole thing in a bracket, because the square root is for everything. So it's going to be to the exponent of 1 over n, of which now it can make a lot of sense. Why? Because we know that we can actually remove this here. We can actually remove this n by just dropping the exponent. Remember, if you are given log m to the exponent of p is same as p log m. All right, so that means here we can be left with pq over r like this, which is equal to, you have to drop the exponent, which is 1 over n. Okay, then we have got log x minus t like this. Now this is one of the stages that we must be very careful about. In actual sense here, I was like supposed to, because this n is in the denominator actually, so for me to make this n in the denominator like this, it's going to be difficult. So what am I going to do is to remove this n here and multiply it both sides, because the moment I multiply it here, it's going to be written on top. So like what I'm saying is, if I multiply by n both sides like this, remember it's an equation, whatever that you do on the other side should be done on the other side like this. So this can actually cancel, just like what we did here. You see that it was p over q, now it's q over r. Okay, someone wants us to write also this one like n over 1, but it's one and the same thing actually, because 1 does not affect. It was 1 over n, so it's n over 1. Okay, anyways, so now you can multiply this n here, so it's on the top like this, n over 1, so it's n times this, 1 times this. Okay, so n times pq is going, let's just write it as it is, npq, so that we don't confuse ourselves, over r, because it's 1 times r like this. So which means you're going to be left with this log alone, just like the previous part. So it's going to be log x minus t like this. But still, n is not the subject, but this time it's an advantage because n is now in the numerator. It's now different from where it was 1 over n. It was going to be difficult for us. So now what can I do? I have to just remove this part here. So how can I remove pq over r? Just like what I did previously, I'm going to multiply by the inverse of this, just invert those terms. So it's going to be r over pq like this. But whatever that you do, because it's an equation, whatever you do on the left hand side has also to be done on the right hand side. Okay, look, now this part is disturbing us. So multiply by r over pq like this. All right, so that means this can cancel and this can cancel, so you're going to be left with n. So n is equal to r over pq times this times log. You can just start by writing this, so it's going to be r over pq like this times log, which is times log x minus t like this. So actually your n is now the subject of the formula. So as you can see, guys, they are testing you. How do we relate when you are given letters? How do you work with letters if you are now given letters, not numbers? Because most of you guys, when you are given numbers, you just use your calculator. But now a letter like PRQ, you can't use a calculator. So that is why they test you like this. Okay, then on 4.4 we have a question which didn't make sense to me, but anyways I have to bring it to you so that you see. The question was saying the sum of two positive integers, take note here, the sum of two positive integers. Integers, you're simply referring to whole numbers. These are integers. So the sum of those two positive integers is what? Is 6. The difference of their squares is 60. Determine the two numbers. All right. I want us to create equations based on what they are saying and see if it is going to make sense at the end. But for me, it didn't at the end. But let's see. We have got two integers in this case that we do not know the values, and they are positive, and we are just given their integers. We are not given that they are consecutive. No, that is not the option. We are not given that they are consecutive. That is a condition where if the first integer is maybe is 2, then the other one is going to be 2 plus 1 because they are consecutive. Another one 2, another one will be 3 plus 1. You'll be adding 1 1 1 1 like that. But this one, they are just integers. You are not given that they are consecutive. So let's just say one integer will be x and another integer will be y. So let x be one integer and y be another integer, because we are not given the order or even, but we are told that they are positive integers. That is where my query was actually on the question there. Anyways, they are saying the sum means to add. If we add the two positive integers, we must obtain 6. Okay, which means this positive integer added to this positive integer must give me a 6. Okay, that's what they said. Then the difference of their squares is 60. The difference of their squares. Which squares? These ones. So if I square this one and subtract to the square of this one, I must obtain 60. That is what they are saying. The difference of their squares. These are the squares. X squared minus. So actually I'm supposed to solve that equation that I'm given. So there are actually so many ways of solving this type of an equation. But let's see. Most of us, if you are given, because these are now two equations, equation 1 and equation 2. So someone can think of making x to be the subject and y to be, yes, we can do that, guys. But okay, let me just do it. Let y be the subject. So just make y the subject there, guys, on equation 1. So y is going to be 6 minus x, isn't it? That is what you're going to have here. If we make y to be the subject here, y is going to be 6 minus x. that will be your equation 3. So you substitute your equation 3 into equation 2 here. So it's going to be x squared minus, in place of y, you substitute this 6 minus x. So it's 6 minus x like this squared, because there's a squared there. Alright, which is equal to 60. Alright, anyways, let's see what, where am I getting this now, which is just 60 there. Now expand this, we are going to have x squared minus, so I want you to expand this. So take note, the minus is going to affect the answer that you're going to have, so you have to open the bracket. So remember, this one you can use the identity, that's going to be 6 squared, which is 36 minus 12x plus x squared, like this. All right, so that is what you're going to obtain, or you expand two brackets separately, it's fine, you're going to obtain the same answer there. All right, which is equal to 60. All right, let's expand the bracket now. X squared minus times this, which is minus 36, minus times minus, that's plus 12, minus times plus, which is minus x squared, is equal to 60. All right, so as you can see, as we are collecting like terms, this x and this x are cancelling each other. So we're going to be left with this part here of minus 36 plus 12x equal to 6. Okay, plus 12x, which is equal to 60. So definitely I have to transpose this to the other side. So it's going to be a plus. So it will be plus 36 like that. So that means 90 plus 36, we are going to obtain 96 there. This is going to give us 96. All right. Then if I divide by 12 because I want to make x to be the subject, or to find the value of x. So this one is going to give me 8. That is the value of x, which is 8. But now something is happening. If we are to go back to the equations that we had here, so that this can relate to what we had. We have this, that 6 minus x, y is equal to 6 minus x actually. All right, so if y is equivalent to 6 minus x, and we obtained that our x in this case is 8, so it's going to be -2. So, but we have done everything nice here and everything is true, but now the question was saying the sum of two positive integers. That is where it's now becoming weird now, because the integer that we obtained, which is only positive, this one is negative. But if we add this to 8 plus -2 like this, we are going to obtain 6. That is what we have. And so you see now how these questions are confusing, and how we are supposed to be very, very careful, because this one was saying positive, but it's not like that. It's just supposed to be integers, because an integer can be a positive or a negative whole number. So that statement was just supposed to be an two integers. That is what the question was, not positive, because this is not positive, this one, but it follows all the concept. And we can't say y in this case is a 2, because maybe if we use it that way to say that y is a 2, but according to the equation we see that we are obtaining a -2. But if we make it a 2, it's not going to make sense if y becomes a 2. I want you to see, because we said the sum. So if we add these two, if we add 8 plus 2, as you can see, it's not going to give us, it's giving us actually a 10. So it's not going to make sense. So this word here was not supposed to be there, this one, so that it can make sense. It's just two integers. Okay, so that is what we had. And also you can also prove the other one that we said, remember we said x squared minus y squared is equal to 60. Okay, which is x squared, that's 8 squared, minus y, or y is -2. So it's negative 2 squared like this. So this one is going to give you a 60. So that means that's what we have. So it was only the question itself which was not asked in a proper manner. So simplify. These are complex numbers actually that you are needed to simplify there on 4.5. That is j to the exponent of 27 minus 4j squared. All right, so remember j squared, guys, gives us negative 1. So this one is actually simplified there. J squared is negative 1. So this one is simply negative 4 times negative 1 like this here. But what about this one? If we are to write this 27 in terms of j squared, so it's going to be j squared, which number that we can use, because this one is not an even number. So which even number is before 27? So the even number before 27 is 26. So that means to obtain to the exponent of 26 from j squared, I'm going to just divide this one. 26 divided by 2, which is 13. Whatever that I get, I multiply by j, because remember I am at 26, but I need j to the exponent of 27, so it's going to be times j like that. So that this gives me 26 times this j, 27. But we know that j squared, we said j squared is minus 1. So it means we've got minus 1 to the exponent of what? Of 13 times j like that. So that's minus 1 to the exponent of 13 from your calculator is a negative. So that's negative j. And here you've got 4, negative and negative, that's a plus 4. So that's 4 minus j. 4 minus j like this. J minus j plus 4 is the same thing as 4 minus j like that. So guys, that's how they ask these questions. And now as you can see, complex numbers and so forth. So some of these questions, for them to be easier, make sure that you also revise from your textbooks. Okay, your textbooks, do some revisions, so that when we are now doing question papers like this, it will be much easier for you to grasp the concept. But anyways, that's what we had, guys, from Amazon African Motives, working on mathematics for N4 level. Till we meet again.